Hi, my name's Dr. Gary Samuelson. I'm really very glad to be here today at this Autism conference. This is the first experience that I've had with an Autism 1 conference, and I have found it to be extremely motivational and extremely inspiring, because here we have actually seen solutions that we can apply in a real practical level to the problems that we have in our society. And these solutions require tools, and we're given the tools through the research that has been presented. But the thing is, we do have these solutions. They are available to us, and thank goodness for conferences like this. We're able to disseminate this information. Today, I'm going to talk a little bit about oxidative therapies, which opens up a whole new toolbox and has actually been included in many of the therapies and things that we've seen today during this conference. So I'm an atomic physicist, and I deal with how atoms work together. I work actually with quantum spins and fields and such. And we have learned in nanotechnology and in other fields that I've been associated with how to make certain structures and functions in atoms and molecules and how they fit together and how they work in life. And as part of this, we start to understand basically that there are certain paradigms, there are certain things that we've always thought to be true that are not true when we look at them a little bit more carefully. Can everyone hear me? All right? Good. And one of them has been in the field of oxidation. And so the question is, well, what is redox? I'm talking about redox signaling, and what does it mean? And so I'm going to put this in a very simple and a hopefully understandable way so that you can understand what this means. Reduction and oxidation actually means the exchange of electrons. It happens in every single chemical reaction that happens on life and in Earth and in our universe. So it's a very, very general thing. When we're talking about biochemistry, though, in our body, we're actually talking about redox biochemistry of antioxidants and oxidants. Now, these oxidants and antioxidants are produced right inside of our living cells, all 70 trillion of them. In fact, they're produced in every cell, in every living form that exists on Earth. And so the biochemistry of these oxidants and antioxidants are involved in what we call the field of redox biochemistry. And so it covers a lot of ground, a great deal of ground. I'm going to talk to you about some discoveries in here. There's a very common antioxidant myth that everybody has ascribed to for a long period of time. And I'll be talking about oxidants almost exclusively. So everything that I'm talking about in this presentation almost has to do with the role of oxidants in our body. These antioxidants were thought to be something that we eat and we take into our system. And they come from fruits and vegetables and all that good stuff over there. And then the oxidants are these free radicals, or these bad guys that crush our cells and take away energy from us and do all sorts of terrible things. They have horns and such. This is actually a myth. So in order to be able to dispel that myth, scientists have been doing a lot of studies lately in the last 14 years that show that antioxidants and oxidants actually are on an equal footing. They're partners, actually, very important partners in our cellular physiology. And the antioxidants that we produce inside of our cells, like glutathione peroxidase and reduced catalase and superoxide dismutase, as well as the oxidants that we produce, like hydrogen peroxide, superoxides, and hypochlorites, are all essential and necessary parts of our mechanism. Redox biochemistry, actually, as a field, has been well documented. Here's one very good, excellent reference, Dr. Ruma Banerjee as she explains how these things work inside the body. James Watson, the same guy that discovered the helical structure of DNA, is now working with redox signaling. He says, in the chemistry of oxidation and reduction reactions, the body cells cannot survive without making both oxidants and antioxidants. There is a delicate balance between the two. Physical exercise prompts the body to make large number of oxidants, molecules called reactive oxygen species. We'll be talking about those. And helps forge chemical bonds, which stabilize the proteins as they fold. There are several books and journals and conferences, in fact, hundreds of publications every month representing actually many hundreds of months of research every month that's available in this field to see what it is. There have been several Nobel Prizes won for redox signaling. One is in nitric oxide, action of nitric oxide. I'm going to go through these kind of quickly now. I have a lot of graphical slides, and they're basically meant just for, entertainment. You don't have to read through them all. But then these guys looked at G protein-coupled receptors and how oxidants react with those. They won a Nobel Prize, for their work. So this reactive oxygen species that we see in our cells actually comes in several varieties. It's a species. I listed several of them up here. We're going to look today at superoxides and hydrogen peroxide. But they do a lot of things inside of our body. One of the first things that we understand is they help regulate our mitochondrial metabolism. In fact, the mitochondria are the things that produce most of the oxidants that exist inside of our cells, our 70 trillion cells. And they produce it through the electron transport chain, which is depicted here between the two membranes of the mitochondria. And these oxidants then help to regulate, or the balance of these oxidants help to regulate our mitochondrial function. When our mitochondria actually stop to function, we get mitochondrial dysfunction, it doesn't produce as many of these oxidants anymore, with grave consequences actually to how our cells are able to function, work. These oxidants are also involved in the immune system. Here we see a white blood cell surrounding a bacteria, and these are the things that actually kill the bacteria. They're antimicrobial. They're the weapon of choice of the immune system. If we didn't have these things in our bodies, we would not be able to kill bacteria, and they have to be effective or else we die. They also, as Dr. Watson had alluded to, they also cause changes in our protein structures that cause signaling. Here's a hydrogen peroxide, for example. When it comes in contact with certain proteins, it'll actually change the shape of them. These become the traffic signals along vital pathways inside the cell that allow the cell to do what it needs to do. Without these oxidants, the cell actually does not function properly. These thyroidoxins, by the way, the reductase can actually turn it back to its original self, and then it goes back and eliminates another hydrogen peroxide. And these are called antioxidant cycles. They're very, very important inside of our cells. Don't worry, I'm coming to a conclusion here. This is just a motivation as to the importance of oxidants inside of our body. Oxidants also regulate the production of insulin. When the oxidation goes up inside of our body, which means the mitochondria are producing more sugar, or are processing more sugars and producing more oxidants, hydrogen peroxide goes up, insulin production goes up. It actually is one of the primary, most fundamental regulators of insulin inside of our body. And when it gets out of whack, when we get too much oxidants in our system, for example, we eat a candy bar that has 2 or 3 or 4 times the amount of sugar processed sugar that our body can handle. it floods the cells with oxidants. The poor beta cells that are producing the insulin inside of our body, actually it's like throwing gasoline on the fire, and all these free radicals and smoke come out, and they try to undo that by creating insulin, which is supposed to decrease the amount of the sugar inside of our body and decrease the oxidation levels. If this doesn't work, then it actually can get out of control and cause problems like diabetes and such, where the system doesn't work. So James Watson has said that reactive oxygen species that we've been discussing and hydrogen peroxide delay, if not prevent, the occurrence and severity of diseases such as type 2 diabetes, as well as dementias, cardiovascular diseases, and then some cancers. Excuse me. And many people, until the 1980s, didn't even recognize the importance of reactive oxygen species as it played inside of our biological systems. Now it's widely accepted, as shown in this and many more, that the ROS plays a role, a crucial role inside of our body. So we have found in this field of redox biochemistry that there are potential applications for the application of oxidants. What am I talking about? Ozone, maybe chlorine dioxide, maybe other non-toxic sort of combinations of oxidants that I'm going to talk about today that can have a great impact in reducing oxidative stress, in normalizing our immune response and hormonal responses, in normalizing the vital brain chemistry and the fluids there, in optimizing the metabolic pathways, and replacing the oxidants sometimes that are lost because of mitochondrial dysfunction. They open the detox channels also and allow the heavy metals to get out of our system. In fact, more than just the heavy metals. They facilitate tissue repair and they facilitate damage detection. And they optimize many of the communication functions of the cell that allow the cells to communicate and work together. So now we're starting to say, wow, almost where do oxidants not play a role in the correct and normal functioning of our bodies? So redox signaling basically is understood if we look at the network between cells as being the structures of life. And this is just absolutely beautiful. Have you ever contemplated just the beauty of the working human body and the complexity of what it entails? It is incredible. All of that complexity and beauty and all of the structures of life have to do with how these interconnected tissues talk to one another. And these interconnected tissues are made out of interconnected cells, of course. And the interconnected cells then are made out of interconnected molecules. And all of the molecules of life are interconnected by a field of water and salt, which actually mediates all of the electrochemical processes, or all of the processes, all biological processes in every form of life that we have on Earth. So this reduction and oxidation of these saltwater compounds that create reactive oxygen species are fundamental to life, and they have been fundamental ever since life has existed on the planet. And we're just starting to figure it out. To understand or to motivate this, look at our cells like sort of an organization or a community of houses. And in fact, here are brain cells. I love to look at this stuff because if you look down from an airplane, you can see these little, buildings and things. They all have streets. The streets are synonymous to blood vessels that carry the supplies and the wastes and everything out of the communities. And So the kind of logistics that allow us to have a healthy community are the same logistics that allow us to have healthy cells. Here's communication lines between cells. Those little green things are actually the telephone wires between the cells and, of course, then the streets that carry the supplies. And so the key to these healthy cell communities, now here we're getting into these beautiful structures of life. Notice the fluorescence in that. Those fluorescent indicators actually are designed to point out the oxidants inside the system. The blood vessels have large networks of cells, they're called in the endothelium, that actually are seen here in this picture, that undergo oxidative stress or produce oxidants. And so therefore you can see them in this picture. It's pretty neat. And we have sewer pipes that take away all of the problems. And it's just about the same thing as this building. Now look at this. This is a wonderful analogy. Inside of our communities, we need to build cells. What kind of things do we need in order to build a cell? Well, it's about the same things that we need in order to build a building. Okay? Cells are damaged all the time. Well, in order to build a building, we need the blueprints. Blueprints we already have in every cell. It's the DNA. In fact, there's several in every cell. We have to decide which ones we're going to use. And the micronutrient supplies are the nutrients that we take inside of our body. These are very specific to the environment that we have. Animals have to take in nutrients that they are accommodated to in the environment they have. For the last 20 million years, as far as we know, all life has been able to adapt to the environment that it is in, except for the human species during the last 70 years or so, because we have changed our food structures and our nutrient structures so much that our body can't even now adapt fast enough. And we'll see the process of evolution go. I have a little kind of a funny joke, you know. They say, you know, there will always be mothers that say, eat your vegetables around. It's a process of evolution and survival of the fittest. So anyway, I think you got, if you can get that, the point on that. But what are these guys in the picture? What are they analogous to? These guys are the guys that look at the plans and then carry the messages to the builders and the workers and tell the builders and workers what to do. These are the messengers. They're the signaling messengers. Redox signaling mediates this messaging system inside all of our cells. Without these messengers, nothing gets done, and life cannot exist. So again, we're seeing the fundamental role of these messengers inside the body. Stem cells are able to differentiate based on messengers in their local environment. And messengers determine individual cell communications and construction methods and everything that is necessary to even build something as complex as a complete organ. So each cell evolves as a function as in relation to its surrounding cells. And this is actually a functioning rat heart that was built out of stem cells. They just put cells together and they talked to each other and they knew how to build this complex structure. Differentiating meaning that each type of tissue was in the place that it needed to be and the area that it needed to be based on the signaling process that takes place. That's how stem cells work. They listen to each other and they build. So anyway, these ROS components of the signaling system can be generated from salt and water. Now, one of the biggest things that I'm going to say today is a discovery at which we have found to stabilize these salt water compounds so that they can be used therapeutically. And so in our bodies. There are things like hydrogen peroxide and oxygen and superoxides and hypochlorites and such that are able to be working together. The problem with these is they're toxic normally, and we have problems with them. In healthy cells, all these toxic elements are produced by our mitochondria, and then they are eliminated by the antioxidants. And you get a perfect homeostatic balance inside all of your cells. Inside a sick cell or a damaged cell, you get what they call oxidative stress, which means the oxidants actually get out of balance. And this oxidation, or this oxidative stress, actually pushes the genetic buttons that cause inflammation, but also they push the genetic buttons that cause the healing response, the cell to repair itself. Without this oxidative stress, it would be like having a fire without smoke. We wouldn't be able to detect what was wrong, and the body then would not be able to respond to fix the cell. So we take the oxidants out of all of the cells, and what do we see? We see in mice premature death. We see cancers and other things which are damaged cells that are not able to be repaired and replaced or detected. The detection of damage and the ability for the body's own mechanism to repair and replace cells becomes compromised. So these oxidants actually are very, very important. The thing is that they maintain balance. And the mechanisms we have inside of our cells actually help that to become. If we see an oxidative stressed cell, what normally should happen in an acute situation is that it recognizes itself and it either fixes itself or it kills itself. And then it's replaced by a normal, healthy cell in the neighborhood, and that makes the balance then be restored, and you get healthy functioning again. So the innovation that we have is, suppose we have chronic oxidative stress, something that genetic switches that have been switched on, we just can't seem to switch them off. How can we actually go in there and express things like NRF2 and antioxidants and whatnot that will help to reduce the oxidative stress, switch off these genetic problems, and or help the body to recognize it? As our mitochondria, by the way, degrade with age, the ability to produce these signaling molecules is decreased. And when the ability is decreased, then they're not able to respond normally. Healing is slower, immune response is slower. Brain chemistry and hormonal responses are slower. So what if we were able to then infuse back into our cells and tissues a safe set or a non-toxic set of these molecules? Now that's something that we thought would be absolutely impossible before because they're toxic. You know, you only can take very, very little amounts of them to have a huge effect. And some of you that have looked at oxidative therapies realize that, you don't want to take very much. You have to be careful about how much you take because they are toxic and they're very potent. But over 30 years now of 30 independent studies, have shown that we actually have achieved ROS in a safe biocompatible form. And it increases the efficiency of the endogenous antioxidants by more than 4 times. That means the antioxidants inside the cell. And it also releases these type of signaling indicators that are defense and switch the genes that need to be switched in order for the cell to repair itself and to get rid of toxins. So we can now directly go in there and start the cell on this repair and replace process. And I have so many stories, by the way, hundreds of stories. I might, if I have time, mention a few. But I'll get into the research that we've done. In cell cultures, we take cells and put them in a dish. And we found that with these mixtures of ROS that I was talking about, there's absolutely no toxicity, no inflammation. It doesn't matter how much you put in them. In fact, they're very happy. The cells don't have any problems at all. It accelerates the death, though, of damaged cells by apoptosis. So if we damage a cell in there, it's more likely to repair or kill itself. And then it increases the hormonal sensitivity in the cell cultures. So, so far, everything positive, no negative toxic effects whatsoever. It also reverses cell aging. And so that old cells start to behave as normal cells. We also have shown, now here I'm going to go through these really quickly. The cells up there that are green are the ones that have no toxicity, and the ones that are actually have in the nucleus, the green dots there, I can't point to it. But this shows that there's absolutely no toxicity no matter how much you put in there. And we've tried this in many different ways. These show that antioxidants and other sorts of indicators are upregulated, or the genes are switched on that help to protect the cells and to do these things. In our preclinical trials, we've showed that they're 100% effective in every microbe that we've ever checked, even the most resistant kind. It kills them. So it has absolutely no effect to the body. You can put it anywhere, do anything with it that you wish, but it kills microbes. Does it kill the healthy microbes, the microbiome? No. It absolutely does not. It does absolutely nothing to them, except it helps normalize, in some cases, the microbiome. So there's no effect on the microbiome. Cell cultures show that inflammatory markers are stimulated, antioxidant efficacies are increased, and it increases sensitivity to hormones. We already went over that. So now we have 10 independent professional clinical studies that show that this stabilized ROS enhances energy utilization in animals. It makes mice run 29% longer on a treadmill. And the mice don't know how to run longer. It's just that they're more efficient. Their cells are more efficient. Human metabolism undergoes shifts lasting more than 24 hours. We see the metabolism shifts happen. Actually, it's shifted toward more efficient energy utilization, we believe. And so these little animals here, we had 20 years of studies on them. There are quite a few effects that we've seen in animals. How about human beings? There's no toxicity whatsoever, no lethal dose found, no abnormal histopathologies. And we've seen, as I mentioned before, in these 5 clinical studies that there's no adverse effects. We've done complex analysis, and the metabolomic results were striking. 60-plus metabolites changed, which are the markers of our metabolism inside the body, and lasted for more than 24 hours. So here's some of the data that shows the shift of metabolites in the body. These are in humans. And then it also shows the different metabolic profiles change with time up to 24 hours after taking 4 ounces of this ROS compound. So we've seen positive benefits in over 50,000 plus cases. Now, at the very beginning, I didn't believe this at all. I didn't believe that we could do this. And we had the compound. It was at my house. And my wife cut her finger. It started to bleed profusely. It was about a 4-millimeter deep cut. It was really quite a thing. And I thought, well, if there's ever been a better time to test it out, why not do it now? So I took a little cup and I poured this liquid in there. It's a clear liquid. Kind of tastes like, I don't know. I hated it. Kind of like hydrogen peroxide pool water. It's not the greatest taste in the world. To other people, it has different tastes. But anyway, I put my finger in it, or I hurt my wife's finger. I asked my wife to put her finger in it. She doesn't do anything without, I don't do anything without her permission anyway. So anyway, she put her finger in it, and the bleeding stopped immediately. And I had never experienced that before. The blood didn't diffuse, or the blood in fact, didn't coagulate. It just sat there. And she took her finger out of it about a minute later and went off cutting vegetables again. I wasn't worried about because the microbes have been killed by this substance, so I didn't worry about her wrapping it or anything. About 4 hours later, it was closed. And the next day, 24 hours later, there wasn't even a mark there to indicate that she'd been cut. So I saw with my own eyes, and that's when I started to realize that we really did have something in our hands that was working. There's a company that I consult for that's called Asea. If you need information, then they have marketed this. So clinical results of topical applications, by the way, one of the best ways to see if it's repairing cells is to put it on your skin. It's very visible. So what we've seen is improvements in wrinkles, these are clinical studies, very good ones, and reduction in blotches and increase in smoothness and elasticity, very professional ones done by 3D mapping of skin by lasers and such. So it's real science. There's results in 28 days on these things. We can see the skin tightening up and repairing itself. There's increases of blood flow to the skin, very significant, about 16% increase in blood flow, decrease of cellulite, the women love that, and it increases the rate of cellular regeneration of the skin, or the skin regenerates itself faster. So, a lot of things there. Musculoskeletal research, by the way. Do you need regeneration and repair of your muscle tissue? Yeah, and I mean, that's pretty obvious. Well, athletes love this. We found that, the stuff isn't up there that I expected, but athletes have found that they are able to go out and really kill themselves, and then not have muscle soreness the next day. So when they're taking this, in fact, there are gold medal Olympic athletes that are taking this now for various reasons. Immune system research. The principal weapons of the immune system and the principal signaling system of the innate immune system is all mediated by this ROS stuff. So we can expect some indications. We don't have all studies in these areas. These are just potential areas. Cardiovascular research, it transmits communication lines throughout this endothelium, like I was talking about. All those signaling pathways inside of our cardiovascular system are enhanced by this. By the way, almost everything that we've done has been done with these endothelial cells in our cardiovascular system. So this is pretty cool stuff for the cardiovascular system. Oh, by the way, inside a living heart, do you know how many mitochondria are inside every heart cell? Do you have any idea? Anywhere from about 4,000 to 5,000 mitochondria are in every single heart cell in your heart. Why is that? Well, one of the reasons is that the heart needs fuel. It can't stop. And the other one of the reasons are that the heart needs this enhanced detection and signaling because it can't stop. The repair and replacement of damaged heart cells is extremely important. And so there are lots of mitochondria, and they're producing lots of oxidants and lots of oxidative stress as a result. Happens when there is heart failure or problems in the heart. So, it's a really interesting thing. But in a normal healthy cell, say an average normal healthy cell, how many mitochondria do you think there are? On the average, about 200. In bone, there may be 20 or 30. In normal soft tissues, there's somewhere in the hundreds of mitochondria in every cell in your body. In fact, about half of the body's dry weight is in mitochondria. And so, the mitochondria are producing these reactive oxygen species. And you can imagine then how much of this we already have inside of ourselves. And here's a kind of a fun little thing that I do often with people. This is called a cell phone, okay? It turns out that all of our 70 trillion cells have one of these guys. They have little bars on them. I don't know how well I get reception in here, but I have 5 bars in here. So if I wanted to call for help, if I passed out here on the stage, or somebody else called for help, I would want them to have these charged cell phones around so that they could communicate and that they could coordinate the efforts that are necessary emergency response efforts, right? If they didn't have a cell phone around, or if they didn't have bars on their cell phone, what do you expect would happen? Chaos. And very much so, this happens inside of our cells. When there's oxidative stress to the point where that it's blocking the signals, and or there are not enough oxidants, there are not enough bars here on our cell phones, then the signaling systems are compromised. And so now the cell says, oh, there's a bacteria over there. Can you hear me now? You know, and it doesn't really work as well as it should. And that's simply because the cellular communication is broke down in this. What these redox signaling compounds do actually are, in a sense, recharge the cell phones. So that's one way that we can look at it. When they recharge the cell phones, then the natural processes of the body, the ones that were given to us by nature in all forms of life, become more efficient. The immune system can become more efficient. Do you know what kind of signaling system a plant uses as far as its immune system is concerned? No? Okay. A plant uses a redox signaling network. You cut a plant, it creates oxidants. It's the same thing as the people do, as any cell. It creates oxidants. The oxidants become the signals that bring in all of the repair and replace mechanisms that the plant has available to it. Not very much different than, you know, what our bodies do. So now, in your minds, is there indeed application for these oxidative therapies in the medical fields? And possibly can they help? I'm actually constrained by legal restrictions here and what I can say, can't say. But I can tell you that I receive emails from many communities of people telling me the responses that they've had toward these oxidative therapies. And lives are restored. And there are a lot of people who are very grateful that these sort of things are coming out now. Now, I don't claim to have complete control over this field. In fact, if you would look at the field as a whole, we've only looked at a tiny sliver, and the rest of these fields are in, you know, inflammatory processes, oxidative stress processes, and other things. But this redox signaling process affects them all. It's fundamental, as we had gone through, to all of the organs and processes of life. It's fundamental to our endocrine system, or our hormonal balances also. You know how hormones are also received. They have receptors. Now I wanted to kind of tell you a little bit about the cell again. Hormones, I believe, are like mail. You know, in your house, in your cellular communities, like the community of houses, you have mailboxes. But the mailboxes on the cells are spread all over the outside of the cell. And they sort the mail, and the ones that are supposed to be there are brought in. The ones that are not are kind of passed on to the next. So there's a very important sorting process. If you want to send a hormonal message, you send it through the blood system, and it's received by these mailboxes in specific cells that are supposed to receive them. These mailboxes operate on the principles of redox signaling. Again, there are hugely complex processes that I'm not going to go into, but being able to increase the redox potentials in the vital fluids is like like lubricating the mailboxes. So they become more efficient in how they receive mail. And that can help all sorts of hormonal imbalances fix themselves. You know, if you get the system to operate more efficiently, a lot of things just kind of helps, just kind of fixes itself. We're talking about environmental deficiencies that we've experienced because of the food sources that have changed and whatnot. One of the ways that we can combat that is to replace or replenish these deficiencies in our body. And these things are available to us. One of the things that we can now replace or replenish are these signaling messengers also in our body. And I'm going to go on a little bit. Actually, I'm running a little bit early, so I might have some time for questions if that's allowed here. But just a second, just two more slides here. So in nervous system research, we found that all the nerves require redox balance in order to function. That's not anything, there's nothing new there. And that they also are very sensitive to oxidation because 20% of the oxygen that we breathe is used in the brain. And the mitochondria actually consume about 90% of the oxygen that we breathe. So you know, a lot of that is happening inside the brain. And this redox balance then inside of our brain cells is absolutely crucial and critical to how the brain functions. The passing of signals. The brain is the master signaling guy. His cell phones have to be charged and going all the time. So, you know, that's fascinating. Absolutely fascinating to me. I've studied brain on a molecular level as well as on a theoretical level, and it's just absolutely fascinating how we can associate patterns in our brain to different things. And today we've seen a lot of that too. So studies on lung endothelial cells show that there's increase in glutathione peroxidase, and the tissue is renewed much faster. As we breathe oxygen into our lungs, it's exchanged in these lung endothelial cells. Oxygen exchange then allows the blood to be oxygenated and carried to the rest of the body. So, and so this is very important. How about in our current digestive system? Dr. Bush, by the way, yesterday, excellent lecture by Dr. Bush, showed how these brush cells, they call it, these brush cells, and how the tight binding proteins that hold these things together are affected by the environment and also by oxidative stress. So these brush cells in all of our gut linings, they only last about 4 days. In 4 to 5 days, the whole intestinal lining has been renewed, has been repaired and replaced. And so redox signaling, is as we mentioned, is the process by which damaged cells are detected, repaired, and replaced. It's actually very important in the intestinal linings of our cells. In fact, if we want to ask the questions, you know, how effective are these redox signaling molecules, that we've called them, in different areas of our body? Well, actually, the areas of our body that regenerate faster or use more oxygen actually are more affected than almost any of the other places. Bones are not affected so much unless they're broken. The cells that utilize oxygen and signaling, like your brain cells, and then the soft tissues of the body that are constantly being regenerated. Doesn't exclude a lot. Yeah. So no, I just wanted to say to make a one comment, then I'd love to take a question or two. I believe that because of the universal nature of this system and understanding all of these processes on the most fundamental, basic cellular and molecular level will spearhead some of the greatest advances that we will see if we're allowed to in the medical field this century and beyond. This is a fantastic technology, and I am so grateful to be the person that's able to introduce it to all of you. Thank you. Yeah, I'm sorry, I think she was waiting. Yes? Right. So to the layman's eye, salt water. So how do you get those redox signaling molecules into the water to make it available for consumption? Yeah. If I were to pull up how the mitochondria does it, you saw the electron transport chain. It has certain potentials and certain catalytic processes. We use about the same process. So we take the salt water, and then we use an electrocatalytic process that takes about 3 days. Our body does it in about 3 millionths of a second. It takes about 3 days for us to do it in the laboratory to produce and cause these to be in stable and non-toxic form. Yeah. No, actually, I came out here on my own dime. I'm kind of flying solo here because of my association with the autism community and with Terry, bless her heart, who's put this on. Well, I can't answer any of that question because I'm a consultant for the science, and so you can talk to me after, and I'll give you some information. Oh, I'm sorry. She was saying, how. Her first question was, well, how do we produce these things in the laboratory? And I tried to give her an answer. And the second one is, well, how do you get them? And I said, well, I can't. I'm not at liberty. I'm only a consultant, or I only do consulting work with them. So, but I can hook you up if you need it. Yeah. Did you notice the ROS species that I was talking about earlier? Oh. Okay, ROS species, let me pull up the slide if I can get it. Sorry about this, guys. Here are a few of them. Hydrogen peroxide, hypochlorites, and superoxides in oxygen. You can look up, you can Google reactive oxygen species, or you can look it up in a biological text, and they're listed in there. Well, what we use is... Yeah, okay. That's a good question. When I first saw this compound, they gave it to me. I wasn't going to touch it with a 10-foot pole. In fact, I put it downstairs in my refrigerator where nobody could get to it. It doesn't need to be refrigerated, by the way. It's stable to the point where it's okay in room temperature right now. But because it has some of these things in it. But I looked through these 20 years of clinical tests that show absolutely zero toxicity. So that's what, I can't tell you why. That this certain combination is non-toxic, but we certainly have about 20 years of data, and there's absolutely no question about the toxicity of this product. One of the reasons that you might want to think about is that since we have 200 mitochondria in our cells producing this stuff already, the body already knows how to deal with it. So if we get the mix right, if we get the composition right, it's just like we feel we have. It's the same as in the vital fluids of our body, and so we can put it in our eyes, and you can put it in your ears. Heavens, yes. I down about 8 ounces twice a day of this stuff, and I put it in my eyes whenever I have, irritation. It goes away very quickly. It's very soothing. Yeah. Uh-huh. Well, I can say that it's safe for children, and children usually, if they're normal, healthy children, have no deficiencies, usually have enough of these redox signaling components in them, they heal fast, their immune systems work quickly, that you don't need them. But in your community, it is safe, and I have things that I can't say. But I would say, in more than half of the cases, in a month, you can see, or even earlier, you can see very good things. Oh yeah, almost immediately. Yes. Yes. Well, we're talking about the reconstruction of our cells down there, and yes, I've used it in Mexico extensively as I've been traveling there. I never am without it. Yeah, sure. I'm sorry? The compounds? Yeah, it's the same composition that is in this product, Asea, that we mentioned. Asea. Yeah, so you can, if there's questions about the product, I can't answer them right here, but yeah. Absolutely yes, and please. It just makes those processes more efficient. Yeah. Mm-hmm. Yeah. Well, the antioxidants, unless you're doing IV antioxidants, are usually food-based antioxidants. Are you talking about? Uh-huh. No. In fact, it works in conjunction with antioxidants. Yeah. That means basically that when the cells are stressed to the point that they're producing oxidative stress, and you put this in here, the cells that have this compound are 4 times faster at eliminating the oxidants than the cells that do not have this compound. Does that make sense? Yeah. Yeah. Well, ozonated water is great, but again, it's not a balanced or non-toxic formulation. And so you might get inflammation and such caused by too much of it if you're not careful. This is nice because you don't have to be too careful with it. Yeah. The company that I consult for, Asea, has been on the map for about 5 years now. Yes, they've been selling it for 5 years. That's a good question. I would really like to know the answer, other than that the healthy or good bacteria somehow evade also the immune system and everything else. So the body pretty much knows how to deal with that community of the microbiome. Yeah. Okay, I can't again comment on anything that deals with the disease, but I can make the general comment that is that have anything to do with cellular repair and replacement? Yeah, so this basically just helps the damaged cells to better or more efficiently replace and repair themselves. Increases the probability that something positive will happen. Yeah. Sure. The tight junctions in the gut. Tight junctions we haven't looked at. In fact, I'm going to get together for lunch with Dr. Bush, and we're going to be talking a little bit about that because he has looked at it. And he regularly, in his research, uses these compounds also. Well, no, he researches it, and I don't even know what he does, so I can't represent him. But I'll find out today. Yes, I'm sorry. Constipation. I've used it to become more regular, but I don't have too many problems with that. So I'm just one. Yeah. The question was, is this stuff similar to chlorine dioxide? And the answer is almost the same as that of ozone. Chlorine dioxide is not in the natural ROS components of the cell, but it is an oxidative compound, and it can cause oxidative stress, and it can be inflammatory, and it can be, you have to also be very careful about how much you take. Again, with this compound, since it's non-toxic, we don't have to worry about that sort of things, but we do get oxidative therapy type things happening. I'm sorry. Yeah. What's preventing it? Right now, I can tell you a personal story. Okay. In order to develop a pharmaceutical, you need about $800 million. I'm out of time. Okay. We had a pharmaceutical company come to our business. I was there as the consultant, so I know it happened. They said, okay, I think you have something here. We'll give you everything you need. We'll give you a check big enough, but we're not going to allow you to distribute it to the people. And we said, well, okay, hold on a second. We have several people that without this we are gravely concerned about. And they said, we don't care. If you want to do business with us, this is what you got to do. And we said there has to be another way. They would have gone through the $800 million of research, and they probably would have picked one indication, but since this is so universal and covers so many areas, who knows what they would have done with it. Yeah. All right, that's it. Thank you.